Okay, so it says you are given an interest rate of 8% compounded continuously. That is the key word. Compounded continuously is the formula per, right? A is equal to P times E raised to the RT. Put down amount, interest rate, and time in the account. E is just a number, approximately 2.7. We want to get technical, but we use the E button on our calculator. So, for 10 years, and you deposit $200. So our initial amount is $200. And then E, our interest rate as a decimal is 0.08, and then times 10. What do you get? How much money are we going to have?
445.11.
0.11?
No, 400.
Oh, 445. Okay, so we made quite a bit of money. I mean, it was 10 years, so $245, right? And 11 cents. Better than nothing, though. So, fun fact for you, true story, in fact. My grandparents' parents, so my great-grandparents, they didn't believe in banks, and they made a lot of money, and they would store money all over the house instead of putting it in the bank. So they would have money just sitting around their house, and if they had it in a bank, they'd be getting interest, and they'd have it in mattresses, in walls, in just all these different compartments. And they sold the house, and they thought they had got all the money out after they passed away. And the people that bought the house, a few years later, came and told my mom, because my mom is also a high school teacher, and one of her students came and said, "You know how we bought that house?" And my mom said, "Yeah." And she said, "We found a significant amount of money in the walls, but it was their money. Legally, it was their money since they had bought the house. And they would not tell us how much money." Crazy, right? So, no, oh no, they kept the money. Scumbags. Right. So, if they would have put it in the bank, though, instead of sitting under a mattress, they could have been making money, right? That's my point with that story. Okay, so now it says, if the interest is compounded bi-monthly, so this is a different formula. This is the one where it's not just yearly, it's multiple times a year. So this is the formula, right? It's P. So A is equal to P times 1 plus R over N raised to the NT. So our put down amount is 200. 1 plus 0.08. Bi-monthly, how many times in a year?
24.
24. 12 times 2. So 24 raised to the 24 times 10. How much money there? 444.52. So pretty dang close to that interest rate. Okay, awesome. Moving on. So recall using the one-to-one property to solve for x. So just remembering what we learned last time. 3 to the what power equals 1 over 27. Remember, if we get both of them in base 3, this is just a reminder, right? So we have 3 to the x power. If we can get this side in base 3 to the something power, we can solve very quickly. 1 over 27 is 3 to the what power? Anything? Yeah. Right? Fantastic. Go 3 to the first is 3. 3 to the second is 9. 3 to the third is 27, right? Flipped over a fraction makes it just a negative. So don't we know that since this is base 3 and this is base 3, that x equals negative 3, everybody? Okay, awesome. So looking at this one, can you remember how to do it? Give it a try. Whiteboard, go. We're going to actually solve later on, learning how to solve these using logarithms. But right now, we're using a different method. Getting them in the same base. Okay, guys, we got to be able to recall what we learned previous times. So isn't this base 3 technically?
Yeah.
Base 3 to the negative 1 power, isn't it? Same thing as 1/3, right? So we have 3 to the negative 1 raised to the x plus 3 equals, I'm going to write this as base 3 since this is base 3, 3 squared, right? Because we have base 3, we're on the right track. Raise a power to a power and you multiply the power. So let's keep simplifying this side of the equation. 3 to the negative 1 times x is negative x. Negative 1 times positive 3 is negative 3, which equals 3 to the second power. Now that we have base 3, we can simply solve using those the exponent here. So we have negative x minus 3 equals 2, solve for x. negative x equals 5, x equals negative 5. Did you guys get that back there? That you got it? Good job.
I got that.
No, you didn't.
Yes, look.
Oh, I didn't see that. Are you sure? You're a BSer.
No,
yeah, you're
swear.
such a BSer. Okay. Awesome. Okay, so learning the new lesson. Today we're going to get into the basics of logarithms. They're used very much so in calculus. So last time we got into the basics of exponentials, today we're getting into the basics of logarithms. So recall, exponentials have the form y is equal to a times b to the x. Where a is your initial value, so in this one our 1 is our initial value. This is the same thing as this. Y is equal to 1 times 2 to the x. And 2 is our growth factor. 2 is greater than 1, so it's a growth, exponential growth. So I graphed y is equal to 2 to the x. What we're going to do is we're going to find the inverse and graph the inverse of y is equal to 2 to the x. Remember, to find the inverse of a set of x, y points, don't you just switch x and y? Yeah. So look over here. I switched x and y. So first of all, looking at the blue points, this is the points for y is equal to 2 to the x. How did I get that? I plugged in 0 and got 1. Everybody know what I'm doing? I plug in 1, I get 2. I plug in 2, 2 squared is 4. I plug in negative 1, 2 to the negative 1 is 1/2. I plug in negative 2, that's 2 to the negative 2, which is 1/4. Okay, so I have plotted those points. Here's my blue exponential growth. Now to find the inverse, I switch x and y. So notice, instead of having negative 3 1/8, I'm going over 1/8 down 3. Look, over 1/8 down 3. Everybody seeing it? Okay, then over, instead of, I'm graphing the inverse, so I switch these two, x and y. So now I'm going over 1/4 and down 2. Now I'm going over 1/2. Down 1, there's that point. Now I'm going over 1 up 0. Boom, boom. Now I'm going over 2 up 1. And then I'm going over 4 up 2. So there's my red function. That's a logarithm function.
Wow.
So a logarithm is the inverse of an exponential function. Okay, so I just said it. A logarithmic function is the inverse of an exponential function. And vice versa, also, an exponential function is the inverse of a logarithmic function. So write this down. This is the form of a logarithm. Y is equal to log to the base a of x. That's what a logarithm is going to look like if a to the y equals x. I'll explain in a minute. So guys, a logarithm undoes an exponential, and an exponential undoes a logarithm. They're inverses of each other. So this is read like this. So y is equal to log to the base a. So notice I wrote that down there. Log to the base a. So the a will be the little thing written down here in the corner. Log to the base a of x. That's how you read it. Log to the base a of x.
Wait, is x like,
no, this is not an exponent. It's log to the base a of x like this. Of x, like in parentheses. Log to the base a of x. That's what our function will be like. IFF is a mathematical if. It means if and only if. So IFF means if and only if. If and only if. So this is a logarithm if a to the y equals x. Okay, do we have that written down? So the equations log to the base a of x and a to the y equals x are equivalent. So for example, you guys, look up here. So I just teach this a little bit different than a lot of people do. So for example, guys, if we have log to the base 3 of 9 equals 2, it is also true you could rewrite it as 3 squared equals 9. So how did I do that? I'll show you. How do we undo log to the base 3? Well, what undoes a logarithm and exponential? So log to the base 3, to undo log to the base 3, we would take base 3 of both sides, because exponentials undo log. So do you see how I took base 3 of both sides of the equation, everybody? Base 3 and log to the base 3 cancel out. They're inverses of each other. So that leaves me with 9 equals 3 squared, which isn't that a true statement? 3 squared equals 9. So do you see how you can switch back and forth using inverses? Logs, exponentials undo logs. You see what I did? No, we took base 3 of both sides. Meaning we did, like, you know how 2x equals 4? How do we undo 2? Divide by 2, because that's an inverse of multiplication. To undo log to the base 3, we took base 3 of both sides. This is a base, right? Base 3 raised to the second power. Do you see how I took base 3 of both sides? It's not. No, we're taking base 3 of both sides. Yep, so that becomes a 1. It undoes each other just like multiplication undoes division. Leaving me with 9. Everybody good? And then we have base 3 squared, which is just a truth statement. So it's just rewriting it. It's just an easier way of rewriting it, like thinking of rewriting it. Okay, so everybody look right here. If I said to you, rewrite this as a logarithm, do you see how this is base 5 to the third power, everybody? Isn't that how exponentials work? This is the base, this is the exponent, guys, right? Yeah. So that's why I'm calling this base 5. So how do you undo exponentials logarithms? So to undo base 5, we're going to take log to the base 5 of both sides of the equation. Log to the base 5. So now over here, log to the base 5 undoes base 5, dropping my 3 down. Which equals, over here we took log to the base 5 of that. So we have equals log to the base 5 of 125. We're just rewriting this. So like, there's no unknowns here. Like, there's no unknowns. You see there's no x's? We're just rewriting it. We're switching back and forth. They're equal. Everybody good? Yeah. Okay. So as it said to you, evaluate log the base 2 of 32. We could rewrite it as an exponential and solve it that way. So everybody, here we go. We don't know what this is equal to, so let's set it equal to x. Everybody watching what I'm doing here. Okay, now let's rewrite it as an exponential, because exponentials, if I took away your calculator, would be the best way to tackle this. So we need to rewrite it as an exponential. This is log to the base 2. To undo log to the base 2, we're going to raise both sides to the base 2. Exponentials undo exponentials undo logs, logs undo exponentials. Is everybody following? Yeah. So now on this side, base 2 and log to the base 2 cancel out. So we have 32 equals 2 to the x power. And now let's use our one-to-one property to solve. Do you see how it's easier to solve an exponential sometimes? Okay, so we have 32 to the what power? If you don't know, try it. 1, 2, 3, 5. 2 to the 5th equals 2 to the x, right? So x equals 5. So log the base 2 of 32 equals 5. So we just changed it to an exponential and solved that way. Evaluated it that way. Does that make sense? Okay, so let's do this one. Log to the base 3 of 1. If it says evaluate, let's rewrite it as an exponential and evaluate it that way. So let's set it equal to x, and let's rewrite it. To undo log to the base 3, we're going to base 3 both sides. So base 3 and log to the base 3 cancel out. We have 1 equals 3 to the x power. Well, let's try that. That's a good thought. But 3 to the first power is not 1. 0. 0. Good. Any base to the 0 power is 1. So we know that this equals 1. We solved it using this one, right? X equals 0. 3 to the 0 is 1. Does everybody see how that works? Yeah, but it's not exactly what I just did. No, any base to the 0 power is 0. Okay, it's 0. Good point, Rebecca. It's 0, right? Guys? Not 1. Did I confuse anybody? Okay. Here we go. Log to the base 4 and 2. So you guys give that one a try. What do you get? Guys, set it equal to x. How do we undo base log to the base 4? So we're doing 4 to both sides, right? Yeah. So this undoes this, right? Yeah. What the heck? So we have 2 equals 4 to the x power, correct? Correct. Okay, so now 4 to the what power is going to equal to? 1/2. So the answer is 1/2. Log to the base 4 2 is, you just said it, 1/2. Does everybody understand? Okay. Because the square root of 4 is 2, so that's what they knew.
Wait, you have to use the brain.
Yeah, or think, yeah, kind of.
Like you can't like this.
No, you could. You want to see?
Yeah, that was the one.
Okay, that's a great question. Let's do it algebraically. So this is 2 to the first power equals 4 is 2 to the second power, right? Yeah. So we have 2x, because this is technically what we're looking at, right? So then we have 1 equals 2x. So x equals 1/2, if we wanted to do it algebraically. You got to get it in the same base or just think about it, yeah. Okay, so let's do this one. Set it equal to x. So we undo it by base 10. So we have base 10 undoing log to the base 10. 1 over 100 equals 10 to the x power. This one's really easy. X equals -2, right? So log to the base 10 of 1 over 100 is -2. That would be our answer. So what we're doing, guys, is we're using the fact that a logarithm and an exponential are inverses of each other. We're taking a logarithm, and to evaluate it, we're putting it as an exponential so that it's easier to evaluate without a calculator. Everybody good? Okay. -2, wasn't it? Yep. Okay. Okay, so here are some properties of logarithms. If we have log to the base a of 1, it's going to be 0. Because base a to the 0 power equals 1. So these are some properties of logs. You can take a picture, you can take some notes. So if we have log to the base, any base of 1, our answer is 0. Because any base to the 0 power is 1. If we have log to the base a of a, those will cancel out. Won't our answer be 1? Yeah. Okay. If we have log to the base a of a to the x, won't those cancel out and we'll get x as an answer? So does everybody see why this is working out? Yeah. And then also, if we have base a raised to the log of base a, those are inverses, so they undo each other and we get x. That's one thing that Miss Summers came and told me is, make sure you hit hard on this year, because my calculus students are having the hardest time with remembering that base a raised to the log of base a are inverses of each other, undoing each other, giving us x. Does everybody see what I'm saying? We're going to see some examples in a second. And then also, if we have log to the base a of x and we have equals log to the base a of y, because they're both 1 log to the base a and 1 log to the base a, we can just say that x equals y due to the 1-to-1 properties. Just like if we have 2 to the second power equals 2 to the x, that we can just say x equals 2. Does that make sense, everybody? So if you have log to the base a of x and log to the base a of y, since they're both log to the base a, you can then conclude that x equals y. We have 10 minutes till lunch, it says. 10:50, Monday. Second, third period. And then lunch starts at 10:50 to 11:10. Does everybody have those written down? But this is, and this has the same thing. Do you guys understand this, right? This is like the same thing as you have 2 to the x equals 2 to the second. Because they're the same base, you can just say x equals 2. Right, everybody? Yeah. So this is the same thing. Base A, so x equals y. Do you get what I'm saying, guys? Yeah. Okay. So it's all like very straightforward. Okay, so if I said to you simplify, there's many ways you can do it. But let's just think about it. Log the base 4 of 1 is 0. Why is that? Because 4 to the 0 power equals 1, right, everybody? Yeah. Okay, so then what about this one? Log the base 3 of 3 squared. 2. Doesn't log the base 3 and base 3 cancel out? My answer is 2. Everybody see how easy that is? That's what she said people are struggling with in calculus. Yep. So let's do this one. Log the base 4 of 1. 0, isn't it? Why is that? Because 1/4 to the what power equals 1? 0, right, everybody? Yeah. Okay, so what about this one? Log of square root of 7 of square root of 7. 1, right? Doesn't log to the base square root of 7 and square root of 7 cancel out? Yeah. We get 1. Very good. So what about this one? 6 raised to the log of base 6 of 20.
20.
20. 6 and log of the base 6 cancel out. Our answer would be 20. So smiley face, log to the smiley face of heart is heart because all smiley face and log to the smiley face cancel out. Okay, you guys get how this works. Don't forget it for calculus. Okay, solving simple logarithms. So look, log to the base 3 of x equals log to the base 3 of 12. So isn't it a true statement to say x equals 12? Log to the base 3 and log to the base 3. Now why does that work? Because couldn't I go like this? Base 3 of both sides? Guys? So doesn't 3 and log to the base 3 cancel out? Doesn't 3 and log to the base 3 cancel out? Thus, x equals 12. You see how easy that was? Okay, let's do this one. Log of 2x plus 1 and log of x. Isn't it a log of, and this is actually log of the base 10. If there's nothing there, it's base 10. I was going to tell you that next, but might as well tell you now. There's nothing there, there's base 10 there. So couldn't I base 10 both sides, base 10 both sides? Guys? If there's nothing there, it's base 10. That's just something I was about to tell you in a minute, but I might as well tell you now. Do you get what I'm saying? Log to nothing is really base 10. It's not going to write 10 though. Just like square root doesn't put a 2 in there. Do you get what I'm saying? Okay. So base 10 and log to base 10, base 10 and log to base 10. So isn't my true statement 2x plus 1 equals x? 2x plus 1 equals x, solve for x. So you said x is equal to -1, which is true. So look, log to the base 4 and log to the base 4. So can we just say x squared minus 6 equals 10? That easy? So we'd add 6. So we have x squared equals 16, and then we would square root both sides, right? Yeah. So x equals, way to remember that, Dylan, plus and minus 4. Good. Questions? Pretty straightforward, right? Everybody feeling like it's straightforward? Yeah. Okay. So it says write each in exponential form or logarithm form. So I have log to the base 3 of 81 equals 4. What would I do? Base 3 both sides. Log to base 3 and base 3 cancel out. So 81 equals 3 to the 4th power. And then your statement should be a true statement. That is, so we're good. All right, let's rewrite it as a log. It's base 8, so we'll take log to the base 8 of both sides. Log to the base 8. So now log to the base 8 and base 8 cancel out. Dropping my 2 down. 2 equals log to the base 8 of 64. You don't need, no, we've evaluated it. Isn't log to the base 8 of 64 too? So there's no calculator or anything involved. It's just rewriting it. You see how it's just rewriting it? There's no solving here. Like we already have equal signs, you know what I mean? We're just being able to rewrite it back and forth. Okay. So do 1 through 29 odds. Ready, go. This is part of your homework. So I'm giving you homework time. Go for it. Now, to be able to graph a logarithmic function, the easiest way is really to think of it as an exponential and then just switch x and y. Because that's what a logarithm is, an inverse of an exponential. So if we were going to graph log to the base 3 of x, let's first just think of some xy points from, let's rewrite it as an exponential. So we would do base 3 of both sides, you know what I mean? So that's 3 to the x. You get what I'm saying? Switch x and y. Do I need to do the algebra with that, maybe? Okay, so that's y. If we started with y is equal to log to the base 3 of x, how do we, base 3 of x, how do we find inverses? We switch x and y, right? First step, guys? So we have x is equal to log to the base 3 of y. Now, how do you get y alone? How do you undo log to base 3? Base 3 both sides. So do you see how we have y is equal to 3 raised to the x power? Let's just think of those xy points and then switch those x and y's to graph our log. So 3 to the -1, or like let's do -2. Wouldn't that be 1/9? Guys, 3 to the -2 power. Good. So then -1 is 1/3. So then 0 is 1, and then 1 is 3. Correct? 2 is 9. So to graph the logarithm, we'll switch those. So we'll have 1/9 over 1/9 down 2. Correct? And then we'll have over 1/3 over a little bit more and down 1. And then over 0 over 1 up 0, correct? I'm switching x and y. and then over 3 up 1, over 9 up 2. So our logarithm looks like this. Pretty easy, right? So what's our domain of our exponential? Remember? What's our negative infinity to positive infinity, right? Of our exponential? What's our range of our exponential? Remember that? 0 to infinity, guys, right? This is the exponential. So our range is 0 to infinity, not including 0. So we have a horizontal asymptote, right? Guys? At y equals 0. So now, what's our domain of our logarithm? 0 to infinity, isn't it? Guys? Gotcha. 0 to infinity. You're answering for the logarithm. What's the range of my logarithm? Good. All real numbers are negative infinity to positive infinity. So this one has a vertical asymptote at x equals 0, right, everybody? Our logarithm will. So does that make sense? Just think of it as an exponential, switch x and y. So if I said to you, graph the shifted logarithm, we could rewrite it as an exponential. So we could think of it as an exponential, for example, but wouldn't my exponential be 3 raised to the x? Guys?
Yeah.
Okay, let's just determine our shifts, first of all. What's this? Left 1, shifting for all functions work the same, up 2. So if we have these x, y points, to find the inverse, we switch x and y, right? Guys? So won't we be at over negative 9 down 2? But then are we shifted left 1, right? Left 1, and then up 2. So wouldn't that put me about there? You get what I'm saying, how to graph this. So think about it. If left 1, our new asymptote will be at this left 1. So then won't it look something like this, guys? Will be shifted. So this negative 1, this over a third, down 1 will be shifted left 1, up 2. Boom, boom. About right there. You guys see what I'm saying? And then this point over 1 up 0 will be shifted left 1, up 2. So it's looking something like this more. It's shifted. Let's keep going. Over 9. Did I miss something? 1, 3. Did I already do? No, I didn't. Over 3, up 1. So we're going left 1, up 2. So do you guys see how this is looking like this? A shifted logarithmic function. Everybody pretty good with that? Okay. Yes. Logarithms will always have an asymptote. Okay, so I already said this once, but just a reminder, if you have log with no base, it's always base 10. Just like square root, it goes without being said there's a 2 in there. If we have log to the no base, it's just like putting a base 10 in there. We're going to be also seeing natural logarithms, and that's a logarithm with base e. So log to the base e. Remember, e is just a number. It's called a natural logarithm, and you're going to see it written as, instead of log to the base e, they write it as ln of x. So ln of x just means natural logarithm. So if you see ln, what undoes ln is e, because it's really log to the base e of x. So if I said to you, let's rewrite ln of x as an exponential, you'd say what undoes ln? E. So we'd e both sides. So ln undoes e, just like other exponentials. So it'd be e to the y equals x, but then remember we switch x and y, because it's an inverse. So it'd be e to the x, y equals e to the x. So to undo e, you would do the ln of both sides. Natural log. It just stands for the natural logarithm. So it's just a special logarithm that has log base e. Instead of log base 10, instead of log base 2, it's log to the base e, which will be written as ln instead of log to the base e. So properties of logarithms also hold true for natural logarithms. So if I said to you simplify this, do you see how e and ln undo each other? Because they're inverses of each other. ln and e are inverses of each other. So e undoes ln, and our answer would be 5. We're simplifying. So 2 ln of e. Doesn't ln and e cancel out? So our answer would be 2. So ln of e squared, ln undoes e. They're inverses of each other, so we get 2. E raised to the ln of 12. They undo each other, so our answer would be 12. Does everybody see how easy this is working? Okay, so we've got to be careful here. We have ln of 1 over e. So this is really ln of 1 times 1 over e. What's ln of 1? Isn't any base with a log to the 1 is 0, correct, everybody? So this would be 0. Because ln of 1 is 0, everybody. If you don't believe me, type into your calculator ln of 1. So we have 0 times 1 over e, which is 0. Well, look, ln of 1 over e. Sorry, I didn't mean to put parentheses there. Let me rewrite this. ln of 1 over e. So we could think of this as ln of 1 times 1 over e. Because do you get what I'm saying? That's the same thing. Okay, so then ln of 1 is just 0. 0 times 1 over e is 0. Because any base raised, with of a 1, remember we talked about why that's 0. Because remember that we could rewrite it as an exponential. I don't want to get too technical here. Okay. ln just means, you could just, ln is, you can add it on your calculator, but we shouldn't even be using our calculator with these. Okay, so ln of 1 over 3. What's ln of 1? 0. So 0 divided by 3 is 0, right, everybody? Okay. Okay, perfect. So graphing a natural logarithm, guys, graphing a natural log, if we graph the exponential y is equal to e to the x, remember that we did this last time? Because remember, e raised to the x is just a bunch of, it's just some xy points. E is just a number, right? Remember, we typed into our calculator e to the first, e to the, you know what I mean? E to the -2. So we have these xy points. So if I said to you graph y is equal to ln of x, you could plot those points and then switch them. So that's what I already done for you. Do we all understand if I ask you to graph ln on the homework how to do it? Okay. Okay, it says write each in exponential or log form. So we have ln of 2/5 equals this. So how do we undo ln? E. So we're going to e both sides. ln undoes e, so we have 2/5 equals e to the -0.916. Now we didn't have to evaluate anything. We were just rewriting it as an exponential or log. So over here it says rewrite it as a logarithm. So what undoes e? ln. So we're going to take the ln of both sides. So ln undoes e, dropping 2 down. 2 equals the ln of 7.389. So we're just rewriting it back and forth.
Wait.
So it's the same idea, it's just that special exponential, that special logarithm. It's the same as other logs. It just has a special special base, e and ln. Okay, that's it. So you're going to do 1 through 86 odds. So you can check your work in the back of the book. Make sure you're not using the back of the book to just write down your answers, because it's showing on some of your tests. Some of you went to very high test scores to very low, and I'm skeptical that a lot of you are just the hard ones. You're just looking at the back of the book and saying, oh well. Don't do that. Come get help, and if you're not getting the same answer as the back, don't just say it's okay. Who cares? Come get help. That's what that's there for. So there are those problems.